Thanks, Greg. Well, this presentation is all about improving beef business performance with high-quality forages in central Queensland. My co-author on this work is Fred Chudley, who's the economist on the team, and the majority of our work has been funded mainly by the Queensland Government. I'm also going to talk about some work from a project that was co-funded by MLA, and our current and ongoing work is part of the Drought and Climate Adaptation Program, which is a Queensland Government program. So the previous two webinars in this series, which were delivered by Fred Chudley, presented results from whole farm economic case study analyses, and these showed that for many areas of Northern Australia, perennial legumes are a very profitable investment. For central Queensland in particular, the perennial legumes, and especially leucaena, were the most profitable of all the interventions, all the strategies examined, and they were also the most profitable of all forage options examined. However, annual forage cropping is also common in central Queensland, and for that reason, I'll be presenting some results today or information today for annual forage crops as well as for perennial legume grass pastures. So how do we maximise returns from high quality forages? Well, most producers only have a limited area of arable soil on their property, so they need to make decisions about which forage type they invest in, and then how they allocate that high quality forage amongst different age groups of steers in their herd. So by that we mean, what age should the steers start grazing high quality forage, for how long should they graze, and for which target market. So to answer the question of which forage type to plant, it's important to think about the effect that a forage is having on beef production and business profitability. And so we conducted a project, our DAF team conducted a project in central Queensland. It was an MLA co-funded project. Our target area was the Fitzroy Natural Resource Management Region, shown in the map here to the right. And in this project, we monitored 24 forage sites across 12 commercial cooperator properties over the period 2011 to 2014. And you can see those 12 properties numbered across the catchment there in this map. I should say that in this study, we didn't ask producers to change their practices at all. We were monitoring what they did and gathering data about how their forage systems performed under commercial conditions. We looked at 3 examples of annual forage crops in this project. So we gathered data for forage oats crops, forage sorghum and lab crops. And we looked at 3 types of perennial pastures: butterfly pea-grass pasture, leucaena-grass pasture, and perennial grass-only pastures. At each of these sites, we gathered detailed information to tell us about the quality of the soil in each paddock. We gathered weather data, and we monitored the forage, animal, and economic performance in each of these paddocks. So at the end of this project, we had 31 individual data sets that we could look at. I'm going to give a very brief summary here of the key points, key results from this work, from these commercial cooperator property sites in central Queensland. In this table, we have data for the perennial pastures on the left-hand side of the table, so perennial grass-only data, leucaena-grass and butterfly pea-grass data. And on the right-hand side of the table, I'll present some results for the annual forage crops that we monitored, which were forage oats, sorghum and lab. In the first row of data in this table, we have numbers indicating the average biomass measured in the grazed paddock. So these are the average across all sites and the average across the year. And these numbers are the kilograms of dry matter, of plant dry matter per hectare. In the legume grass cells, you can see there are 2 numbers. The bottom number is the grass component of the biomass, and the top number is the legume component. And for leucaena, that number is the edible component of the leucaena only, so leaves and stems less than 5 millimetres in diameter. So the key points I wanted to make from this row of data was that although these weren't replicated control trial sites in this study, it's evident that the amount of grass grown in these legume grass paddocks was broadly similar to that measured in the perennial grass-only paddocks. The other key point I wanted to make was that the amount of edible legume biomass grown in these legume grass paddocks was a relatively small component of the total biomass available to the animal. So around 10% of the total biomass was actually legume there available for the animals to select. However, the animals selected quite strongly for this legume component. And you can see on average that animals selected about half of their diet as legume when grazing these leucaena-grass pastures. This is the average across the year. For butterfly pea-grass pastures, animals selected about 20% of their diet as a legume across the year. And for the perennial grass-only paddocks, cattle were still able to find about 10% of their diet as C3 species, so that's browse, forbs, or legumes that were naturally occurring in the paddock. And we measured this by measuring delta carbon concentrations in the feces of cattle, which enable us to calculate the proportion of legume that they've selected in the diet. So what's the difference that this legume component makes for cattle? Well, it substantially increases diet quality for cattle when there are legumes available in the diet that are palatable and that are selected. And the two main components that we look at when we're thinking about diet quality are crude protein content of the diet, that's this CP value here, and digestibility of the diet. So DMD relates to dry matter digestibility. And this DMD value is really an indicator of the amount of energy in every kilogram of feed that an animal has. And more digestible diets also allow an animal to eat more. So these are really important parameters that we measure, and we measured these by fecal and IRS analysis in this experiment. So the key points here are that by adding legumes to the diet of cattle, we were able to substantially increase diet crude protein and digestibility. And you can see here that cattle grazing leucaena-grass pastures almost doubled their diet crude protein, and cattle grazing butterfly pea-grass pastures were able to increase their diet crude protein by around 3 percentage units on average across the year. Digestibility was also increased by around 4 percentage units. So combined, these have a really important effect on individual animal performance or daily gain. And combined with the higher stocking rates that these pastures support, because there's an overall greater biomass, the end result is greater beef production measured in kilograms per hectare per year. So you can see there the average across all the trial sites that we monitored resulted in 198 kilograms of beef produced per hectare per year from the leucaena-grass paddocks and 125 for the butterfly pea-grass paddocks, as compared to 76 produced from the perennial grass-only paddocks. We also measured the economic performance of each of these paddocks. We determined paddock gross margins. And to do that for these legume grass pastures, we needed to account for these high establishment costs that have to occur up front. So we determined an amortized gross margin for the perennials. And by this, I mean we accounted for those establishment costs by amortizing or averaging them over the expected life of the forage. So when we did that, you can see that we found a substantially higher gross margin from these legume grass paddocks compared to the perennial grass only. So the leucaena-grass paddocks resulted in almost double the gross margin of the perennial grass paddocks, and the butterfly pea-grass paddocks resulted in around 1.5 times the gross margin of our perennial grass only paddocks. So we'll look now at the results for the annual forage crops that we monitored. At the first line of data here, we have total biomass grown, and this biomass was measured from exclosure sites where cattle were excluded from grazing. So we were able to estimate roughly the total biomass that was grown in each paddock in terms of kilograms of dry matter per hectare available from the animals. So the key point to make from this data is that quite high amounts of total biomass grown in these paddocks relative to the perennial grass-only pastures. And when we look at diet quality on these pastures for the forage oats and lab crops in particular, these resulted in higher diet quality, higher crude protein and DMD compared to the perennial grass-only pastures. The exception was the forage sorghum, and I'll explain about that when I talk to the next row of data, which presents the total beef production per hectare per year from these annual forage crop paddocks. And you can see here that the total kilograms of beef per hectare per year were not all that much greater than that measured in the perennial grass-only pastures, so ranging from 93 to 108 kilograms per hectare per year. And the interesting point to note here is that the forage sorghum beef production was really very similar to what was obtained for the forage oats and lab crops, despite the forage sorghum resulting in around double the biomass grown. So what this is telling us here is that there was quite a lot of wastage from these forage sorghum crops, and we know that under commercial conditions it's very difficult to manage these forage sorghum crops to keep them in a vegetative state, so they become very tall and stemmy very quickly. The stems are not very palatable and aren't eaten as readily as the leaf, and as animals are forced to eat more of that stem, the diet quality decreases. The stems are lower in crude protein and digestibility, and that has an effect on diet quality. When we look at the gross margins from these annual forage crop paddocks, you can see that oats resulted in a fairly similar gross margin in terms of dollars per hectare per year to that obtained from the perennial grass only paddocks, and the gross margins for forage sorghum and lab crops were less than that measured in the perennial grass only paddocks. So they were the gross margin results, but it's really important to realise that gross margins are only the first step in determining the effect of sown forages on farm profit. They show us whether the forage activity makes a profit or loss at the paddock level, but a positive paddock gross margin doesn't necessarily mean that the strategy is going to be the most profitable option for the whole farm business compared to other alternatives. So to determine the value of the sown forage system to the whole farm or business, we need to conduct a more complete economic analysis. And this is one which identifies the change in profit and risks generated by the alternative operating system and includes changes in unpaid labour, herd structure and capital. So we took this approach in a modelling study that we conducted for Central Queensland. It was funded by the Drought and Climate Adaptation Program. And in this modelling study, we used the data that we had collected from our commercial cooperative properties as inputs to inform our assumptions, as well as published research data. And in this particular project, we wanted to look at a whole range of strategies that might affect the profitability, the whole farm profitability of these businesses in Central Queensland, including some high quality forage options. So we looked at a number of strategies that might improve steer growth rates, including legume-grass pastures and forage oats. We looked at a number of strategies that were different marketing options for steers. And we looked at a range of strategies that might improve breeder reproductive performance. Now, the results from all of these analyses were discussed in the first webinar in this series, which was presented by Fred Chudley, called Part 1, Improving the Performance of Beef Production Systems in Northern Australia. And that is available to watch on YouTube if there's interest in that from those who haven't already seen that presentation. What I wanted to talk about was the fact that the standout strategy of all of these that we looked at, other than phosphorus supplementation for breeders, where breeders were running on phosphorus deficient country, the standout strategies were where perennial legumes were introduced into grass-only pastures in CQ. And I'll present some of this data here in this table. The first row of data here shows the change in profit for a strategy of investing in leucaena. And in this particular strategy, we were putting weaner steers onto leucaena and keeping them there until they reached feed on weight. And we were comparing that strategy to a strategy of producing feed on steers from buffel grass pastures, so no leucaena. Investing in leucaena under these circumstances resulted in an extra $40,000 profit per year over 30 years for the beef business. We were able to increase profitability even further by optimising utilisation of that leucaena as soon as possible, so fully utilising it. And we did that in this example by purchasing extra breeders to supply enough weaners to fully utilise that leucaena. And so that increased profitability even further to an extra $46,000 profit per year compared to producing feed on steers from buffel grass pastures. We also looked at one example in this study of planting a shrubby legume, so a small seeded legume such as desmanthus. We believe the results would be broadly similar to Gatinga stylo in this Central Queensland environment as well. And in this example, we were looking at putting the steers onto the legume as weaners and keeping them there until they reach feed on weight, the same as what we were doing for the leucaena. So the desmanthus resulted in around $27,000 extra profit per year over 30 years for the beef business, compared to utilising buffel grass pastures to get steers to feed on weight. A key point to make here for these legume strategies is that investing in these legumes while adding to profit of the business on average over the 30-year period also resulted in fairly large peak deficits from investing in these legumes, and the payback period was substantial, so 7 or 8 years to pay back that investment. We looked at one forage cropping, annual forage crop example in this study, and in this instance we looked at forage oats and putting steers onto the forage oats in their second dry season after weaning to reach feed on weights. And this strategy reduced profit by around $34,500 per year over 30 years. So the conclusion here were that perennial legumes, and especially leucaena, were the most profitable forage option for central Queensland and the most profitable of all the interventions that we looked at. Forage oats reduced enterprise profitability, and in other work that we've done, producer case studies where we've used producers' own data to work with them on farm, we have found that other annual forage crops also reduce profitability in whole farm economic case studies. So perennial legumes are profitable, but how can we fine-tune their management to maximise profitability? That led us to our next research question, which was, what is the most profitable way to incorporate high-quality forages into the whole-of-life steer growth path in central Queensland? And in this work, we wanted to compare leucaena-grass pastures as an example of the most profitable legume-grass pasture with an example of an annual forage crop, and we used forage oats as an example here. With forage oats, we were really interested in whether we could find a more profitable way to use forage oats by looking at all the different types of ways or different ages and stages that we could introduce forage oats within a growth path. So we conducted another modelling study for central Queensland. Again, we used the data that we had gathered from the commercial cooperator properties to inform our assumptions, as well as publish research data. And in this particular study, we looked at 22 different scenarios, and these were all growth paths of steers from weaning through to marketing. The steers were grazing buffel grass pastures, and they received access to leucaena-grass pastures and or forage oats at different ages and stages of their growth path. We compared two different market targets. So the feed-on market target, 474 kilograms, compared to slaughter steers, 605 kilograms in the paddock. And we applied all of these growth paths within two different enterprises, so a breeding and finishing enterprise and a steer turnover enterprise. And we compared each scenario back to a baseline scenario. And in this study, that was turning off finished slaughter steers from buffel grass pastures. In this study, we used a quick intake spreadsheet to calculate intakes and stocking rates. That was a very important component of the project. And this quick intake spreadsheet was the one developed by Stu McLennan. It's based on our Australian ruminant feeding standards and has modifications to better account for tropical diets and cattle. We modelled the effect of implementing each growth path over 30 years, and we compared the marginal returns, the peak deficit, and the payback period of each of these scenarios. So I'll show a series of graphs which demonstrate the growth paths that we modelled for the leucaena-grass pastures. Along the x-axis here, we have months of age of the steers, and on the y-axis, we have steer live weight. The first line on this graph indicates the growth path we might expect on average from steers grazing buffel grass pastures from weaning at 6 months through to feed on weights, shown by this horizontal line here, or finishing weights, shown by the second horizontal line. Across the top, we have dry seasons and wet seasons following weaning. So what we were really interested in all of these scenarios using high quality forages was pushing the growth path to the left. So achieving earlier ages of turn-off by using these high quality forages. And you can see in this first scenario here where we introduced the steers to leucaena-grass pastures from weaning, and kept them there until they reached feed-on or finishing weight, that we were able to shift the growth path to the left so that cattle reached feed-on weights at 9.3 months versus 26.2 months for buffel grass pastures, and finishing weights at 26 months as compared to 34 months that we might expect for steers grazing buffel grass pastures. And then we looked at strategies where we introduced leucaena-grass pastures later and later throughout the growth path. So in this scenario here, waiting until steers were starting their first wet season after weaning until they started on leucaena-grass pastures and taking them through till they reached either feed-on or finishing weight, or waiting until they were at the start of their second dry season after weaning and keeping them on leucaena pastures until they reached feed-on or finishing weight, or waiting until the steers were starting their second wet season after weaning and keeping them there till they reach feed-on or finishing weight. And finally, leaving steers on buffel grass right through until the start of their third dry season after weaning and putting them on leucaena-grass pastures until they reached finishing weight. So we wanted to look at the whole spectrum of possibilities there. So the key findings from these leucaena growth paths were that for both enterprise types, so for the breeding and finishing enterprise and the steer turnover enterprise, there was one growth path that was substantially more profitable than any other, and that was the scenario where steers were raised on leucaena-grass pastures from weaning right through until they achieved feedlot entry weight. And this particular scenario, compared to the baseline scenario of finishing steers on buffel grass pasture, improved profitability by 121% for the steer turnover enterprise. So that equates to around $106,000 extra profit per year over the 30 years of the analysis. For the breeding and finishing enterprise, profitability was improved by 37% compared to the baseline scenario, and that equates to almost $32,000 extra profit per year over the 30 years. For the breeding and finishing enterprise, again, purchase of additional breeders was required to optimise utilisation of that leucaena-grass pasture immediately, and that was the most profitable scenario. However, we found that incorporating leucaena at any steer age, so all of those growth paths that we looked at, increased the profitability of the steer turnover enterprise. And the profitability was increased over a range across all those growth paths of almost $7,500 right up to $106,500 extra profit per year over the 30 years. For the breeding and finishing enterprise, profitability was increased over a range of $1,700 up to almost $32,000 extra profit per year. However, there were two exceptions with the breeding and finishing enterprise where profitability wasn't increased, and those were two scenarios where steers started grazing on leucaena-grass pastures at older ages, so from the start of their second dry season or second wet season after weaning, and they were only left there until reaching feed-on weight. And those two scenarios decreased profitability by $4,800 and almost $24,000 per year, respectively. However, there were potentially negative consequences of too quickly implementing these leucaena investments that were evident through the results of this work, and that was the increase in peak deficit levels and financial risk as a result of investing in leucaena. There were quite long payback periods, so 8 and 14 years for the most profitable growth paths for the steer turnover enterprise and the breeding and finishing enterprise, respectively. And so these need to be considered, of course, when thinking about making leucaena investments. Another important point is that we assumed best practice agronomy when investing in these leucaena strategies. So we assumed all the costs required to effectively establish leucaena according to best practice recommendations, and hence we assumed that establishment occurred and was successful. And so it's really important to remember that correct agronomy must be used to achieve the results that we have achieved in this study. We looked at several scenarios where we combined leucaena grass pastures with forage oats. And again, we were really interested to see if we could push those growth paths to the left and get those younger ages of turn off and a more profitable result. So the first of those strategies is shown here in this light blue colour, And in this strategy, steers were grazed or provided access to a forage oats crop in their first dry season after weaning, and then when the crop finished, were put straight onto leucaena-grass pastures and left there until they reached either feed-on or finishing weight. And it's interesting to note here that the steers reached feed-on and finishing weights fairly similar ages to that for steers that graze the leucaena-grass pastures only all the way through from weaning. And part of that, part of the reason for that is this effect of compensatory gain, which the steers grazing oats don't receive over the subsequent wet season. But steers that have had a nutritional restriction do receive and are able to grow faster and make up some of that difference. So that was one interesting effect occurring there. We looked at providing oats twice in the growth path as well, so in dry season 1 after weaning and the second dry season after weaning with leucaena-grass pastures in between. And we pushed that growth path to the left so that steers reach finishing weights at just under 23 months as compared to 26 months for the leucaena scenario where steers graze leucaena from weaning, or 34 months when steers finished on buffel grass pastures. The results from incorporating oats into these leucaena growth paths was that profitability was always reduced by doing that compared to comparable growth paths that only incorporated the leucaena-grass system. And this was despite decreasing the age of turnoff and despite filling this winter feed gap with higher quality forage. We'll move on now to look at growth paths of steers on buffel grass pastures, but given access to forage oats crops at different ages and stages of their growth path. Again, we have a growth path here for steers grazing buffel grass pastures through to feed on or finishing weight. The first oats scenario we looked at was providing an oats crop to steers in their first dry season after weaning and selling them as yearlings, or putting them back on buffel grass pastures until they reach feed on or finishing weight. We looked also at keeping steers on buffel grass pastures through until their second dry season, when they were given access to a forage oats crop and sold off that oats crop, or put back onto buffel grass pastures until they reached finishing weight. We looked at waiting right until steers were in their third dry season after weaning before giving them access to a forage oats crop to turn them into really heavy bullocks. And we looked at some strategies where we provided oats twice as well. So oats in the first dry season after weaning, back onto buffel grass pastures, and then a second oats crop in the second dry season after weaning. Or putting them back onto buffel grass pastures to reach finishing weight. So the key findings from all of these oats growth paths was that incorporating oats into a steer growth path with buffel always decreased enterprise profitability compared to the baseline scenario of finishing steers on buffel grass pasture. So for the steer turnover enterprise, profit was decreased over a range of $471 right up to $49,000, less profit per year over 30 years of the analysis. And for the breeding and finishing enterprise, profitability was decreased by around $17,000 right up to almost $75,000 per year over the 30 years of the analysis. And of course, investing in forage oats strategies also substantially increased peak deficit levels and financial risk. In this particular study, we didn't account for the percentage of years in which conditions would be unsuitable for planting oats in central Queensland. And in central Queensland, our climate data indicates that that would be about 30% of years and that you just wouldn't be able to plant an oats crop. So if that was accounted for, then profitability would be further reduced. It's also important to make the point that these results don't indicate that businesses that grow oats are unprofitable. They indicate that growing oats is less profitable than utilising buffel grass pastures or legume-grass pastures. There were some other key findings from this growth path modelling study, and one of those was that shifting to this younger age of turn-off, so the feed-on versus slaughter steer market, was generally more profitable when steer nutrition was significantly improved from weaning, as with the leucaena-grass pastures. Also, we found no relationship between the change in profit across these scenarios and the number of extra weaners produced or the amount of extra beef produced per hectare. So the implication of this is that just because a strategy produces more beef doesn't mean it's more profitable. Now, the detail of the work that I've presented today is available in reports and booklets that can be downloaded from the Future Beef website. So this booklet, Feeding Forages in the Fitzroy, contains the data from the commercial cooperator sites that I mentioned. And this second report contains all the detail about the different growth paths that I talked about in the latter stage of my presentation. This document, called Fitzroy Beef Productions Preparing for, Responding to and Recovering from Drought, contains the analyses of all the different options you might consider to improve profitability for your beef business in central Queensland. And this document will also soon be available on the Future Beef website. I'd just like to finish by saying that these results that we've presented today should be considered as examples. An analysis specific to your business should be conducted if you're interested in doing so and investigating these for yourself. And you can obtain more information or arrange a visit from our DAF economists and beef extension officers in central Queensland by contacting Matt Brown in the Rockhampton DAF office, and his contact details are there. And that really concludes my presentation today, and I'm happy to take questions.